to my project based on outcome. Now I am going to explain about the modeling and simulation of hybrid distributed generation and its impact on transient stability of power system. Now I am going to explain the concept of this process. The main objective of this project is to investigate the transient stability of hybrid generation system, that is wind, PV, solar and hydropower generation. The present with the second mixed energies resulting into increasing complexities and instabilities. The dynamic performance is done by considering the impact of the hybrid distributed generation on the grid. This HDG induction with grid contributes more fault current, therefore making the system vulnerable to instability more than a single energy source. Our main objective is to examine transient stability of hybrid generation system. In grid, we integrate the new technologies such as DG and hybrid distributed generation. If more fault current is present in grid, then the system becomes vulnerable to instability. This is the flow diagram of our process. First, we go to design the wind turbine model. A wind turbine or wind power plant is a device that converts kinetic energy from the wind into electrical power. A wind turbine used for charge batteries may be referred to a wind charger. The result over a millennium of windmill development and modern engineering, today's wind turbines are manufactured in a wind range of vertical and horizontal axis type. The smallest turbines are used for applications such as battery charging, for auxiliary power for boats or caravans, or to power traffic warning signs. Arrays of large turbines known as wind farms are becoming increasingly important to the source of the renewable energy and are used by many countries as a part of strategy to reduce their reliance on fossil fuels. This wind turbine result is going to the SPC design. SPC means nothing but the static wear compensator. It is an electrical device for providing fast-acting reactive power on high-voltage electricity transmission networks. SPCs are part of the flexible AC transmission system device family, regulating voltage and stabilizing the system. Unlike a synchronous condenser, which is a rotating electrical machine, a static wear compensator has no significant moving parts. Then the reserve of the large rotating machines such as synchronous condenser or switched capacitor banks. The SPC is an automated impedance matching device designed to bring the system closer to unity power factor. SPCs are used in two main situations: connected to the power system to regulate the transmission voltage, transmission SPC, and connected near the large industrial loads to improve the power quality, that is industrial SPC. Then next is the PV panel design. PV panel is nothing but the photovoltaic design. Why we go for PV panel means then only we go to design the solar cell model. The next process is the synchronizing wind turbine plus the PV panel. PV panel has also separate designs for the temperature independence and also for the power rotating devices. The wind turbine result is synchronized with the PV panel device. The next we go to the solar cell model. A solar cell, also called a PV cell, that is photovoltaic cell. It's an electrical device that converts the energy of the light directly into electricity by the photovoltaic effect. It's a form of photoelectric cell which, when exposed to light, can generate and support an electric current without being attached to my external voltage source, but do require an external load for power consumption. Then next we go for the transient stability performance. Transient stability is nothing but the analysis exacerbate become a major issue in the operation of power systems due to the increasing stress on power system networks. This problem requires the evaluation of a power system ability to withstand disturbances while maintaining the quality of service. Many different techniques have been proposed for transient stability analysis in the power systems. The time domain solutions, extended equal area criteria. Then finally we improve the transient stability as much as possible while we have to use this as the main function file. First, in this process, we design the wind turbine model, that is turbine DFIG model, and double fed induction generator. Then from that DFIG model, the result is going to the SPC, that is a static back compensator. The next we apply the fault displayed in this circuit, that is transmission side, then we have to overcome the fault, so we use the three-phase spark breaker. The next, the process is going to the PV panel, so we design the separate model for PV panel. In PV panel, we give the input as voltage, temperature, irradiance, resistors in series and parallel also. Then from that input, we have to sense the voltage and current by separate the current sensor and the voltage sensor. The next, display in the separate display box. Then we merge, that is synchronizing the wind turbine plus PV panel. The next one is the solar cell model. We design the 36 solar cell models. From the solar cell model, from that only we improve the transient stability. Transient stability is nothing but we have to synchronize both the systems and how we improve the stability performance of the system. From this, I conclude that got an optimized result. The system was observed by using oscillation duration and critical clearing time. In majority investigates the impact of various complementary energy sources on the power system network. Simulation shows the hybrid power system when the generator show a critical cases compared to 2 DG. Thank you.